Learned delegates, invited dignitaries, ladies and gentlemen, good evening to all. I welcome you all to the last session of the day on energy conservation systems. So this session will be chaired by Dr. Ashok Kumar, Deputy Director General, Bureau of Energy Efficiency. So I would request Dr. Ashok Kumar to please come on the dais and chair this session. Thank you, sir. I would now like to invite Mr. Ludwig Lindström, Senior Advisor, Swedish Energy Agency, to join the chairman and co-chair this session. Thank you. To represent NCB, I would like to call upon Shri Pvt Reddy to join the dignitaries on the dais and take this session forward. Thank you.
Also welcome Chairman and Co-Chairman of the session, Dr. Ashok Kumar and Mr. Ludwig Lindström. I would like to have just a brief introduction about our Chairman and Co-Chairman. Our Chairman, Dr. Ashok Kumar, he is a Deputy Director General for Bureau of Energy Efficiency. He is one of the primary member of implementing the national missions on enhanced energy efficiency. This is one of the key effect which has been on COP21 and also NDCs that has been committed by India. And he has also worked in National Physical Laboratory and as well as Energy Coordination Agencies in USA, and as well as he has done in PhD for Energy and Environmental Policy. And now I would like to introduce our co-chairman, Mr. Ludwig Lindström. He is a senior advisor and is from Swedish Energy Agency. He is a senior advisor at SEA and has been working with India since 2009, and he holds 2 MScs in renewable energy technologies and sustainable entrepreneurships. Also have experience in business development in private sector. And SEA is an authority as Swedish side for work under the India-Sweden Industry Transition Partnership under the Leadership Group for Industry Transition, Lead IT. Yeah. Now I request our chairman to please start the session. Thank you, sir.
Thank you. I think, first of all, thank you for giving me this honor with the distinguished co-panelist, co-chair from Swedish Energy Agency, Mr. Ludwig Lindström, and Pvt Reddy from NCCBM. Just to take 2 minutes to say that, we are here to discuss very important subject, energy conservation, and many of you know better than me that energy accounts for around 30 to 40% of the cement cost. So it's a very important aspect, and presentations on this aspect are of very immense importance. So we, as far as the current model of presentation is concerned, we have around 90 minutes at our disposal. So for the best usage of the time, as the keynote speaker has already spoken in one of the sessions, so we would have a good number of time to the presenters. So I would request all the presenters to take around 10 minutes. So 6 presenters, it's like 60 minutes of that. After that, we will have some around 10 to 20 minutes for the question and answer, and then that's how we will structure. So thank you, and I would request if a few opening remarks from my co-chair, if you would like to say.
Thank you very much, Dr. Kumar. Yeah, this is very interesting to me. Coming here with the perspective of the Swedish government, being part of the bilateral collaboration between our countries on industry transition, focusing on steel and cement. So this is part of this activity, is one of our stepping stones in doing that. The purpose with the program is to introduce Swedish innovations and solutions to the Indian industry and co-create solutions for decarbonization of the industry. So I'm looking forward to listen to these papers.
Thank you. So,
now will I request the first presenter, Mr. Prateek Sharma. He'll be giving presentation on energy audit and process optimization of captive power plants for cement industry. It's a case study.
So good evening to all. So I'm going to present a case study on captive power plant for a cement plant, where we have done on energy audit and process optimization. So first of all, we know that electrical energy contributes to around 10% of total energy consumption for cement production, and the average consumption of electricity is in the range of 60 to 70 units per ton of cement. Power mix share, if we see, is around 23, 31%, 21, 18% for the four mixes. Mainly we are using CPP grade WHIS and RE. Indian cement industry has more than 4,000 megawatt capacity of captive power plants. We are continuously working on improving heat rate, reducing auxiliary power and fuel consumption. Many energy audits have created opportunities for captive power plants also to reduce their systems and enhance productivity. So this is a case study of a cement plant which is having a 26.25 megawatt captive power plant. So the plant operates at 25 megawatt at the time of exporting power. Normally it operates at 22 megawatt at full capacity load. These are the equipment specification: boiler, turbine, condenser and cooling towers. Plant heat rate is around 3164 units, and PLF is 61.57%, and auxiliary power consumption is 9.6%, which is on the higher side. So we carried out the energy audit for the plant, all the equipments, boiler, turbine, cooling tower, condenser, and I will show you the findings. So first of all, we carried out the measurements across the flue gas path. So you can see at 24.7 megawatt we carried out the complete audit, and boiler efficiency works out to 86.7%. Normally we have seen around 88% also. O2 at eco outlet, which we say the indicator of excess air, is around 3.6%. Normally we keep it less than 3%. So it's still on the higher side. And there is at the APH outlet, we have 2 points at two ends, and there is a difference in oxygen also 3%, and temperature difference is also around 20 degrees Celsius. So which indicates there is some improper gas flow distribution in this area. So the flue gas temperature measured was also for 147 degrees Celsius, which is also on the higher side. Normally it's around 130, 135. Radiation losses are also on the higher side in the boiler. Then process fan flows, we carried out the flows and we see the efficiency of the fans around 60 to 50-60%. Normally at part load it runs at low operations, low efficiency, and with SF efficiency around 70% we have seen. Then LP and HP heater performance we checked, and we calculated the terminal temperature difference, drain cooler approach and temperature rise of the water. So in HP heater temperature rise is okay as per the design 53, but LP heater it's around 15 degrees Celsius on the lower side, so it should be around 55 at this load as compared to HMBD design, but it running around 40 degree only. Then water condenser and cooling tower. The vacuum we checked, vacuum is on the lower side. Vacuum is the key parameter to check the performance of any power plant, and they're operating at 0.86 vacuum, which normally maintain around the design is for 0.9. So here the potential is there to improve the vacuum, and even the exhaust vapor temperature is also on the higher side, 54.5 degree. Again the design of 45 degree. And if you see the cooling tower approach is also on the higher side, it's 12.8 degree against this 5 degree. So in totality, if you check the cooling water flow, The cooling water flow designed is 4800 meter cube per hour with 2 cooling fans, but plant is running only 1 fan to save the auxiliary power. So they are running only 1 pump, cooling water pump, out of the 2. So then turbine performance also we checked. Its design efficiency 35.7% and heat rate is 2406 kcal to kilowatt hour. But at 24.7 megawatt, the measured we got around 2630, which is very high as compared to design data. So the heat rate is high, plant heat rate is also high, and SSC, specific steam consumption, is also 4.17, as against the design of 3.4. Even extracting pressures and temperature of second stage of the turbine are also deviating from the design values. Ejector steam consumption around 1 TPH, which is high. Normally 0.3 to 0.4 is there. Design was 0.3 in this case. And the deviations in the turbine cycle are mainly due to the high main steam flow and low feed water temperature to the economizer. These are some of the findings. And then we discussed with the plant, and we were sure that definitely if we run both the cooling water pumps, the vacuum will improve and there will be savings, definitely. So we took trial for 2 hours in the plant by running both the MCW pumps. In the existing condition, it was running at MCW3, only one pump. And the steam flow was 97.5 TPH at turbine inlet. But and vacuum is 0.86, what they are running. But after running both the pumps, the vacuum improved to 0.9 as per the design, and all the parameters improved simultaneously. Steam flow also reduced 4 TPH, which is significant, and boiler feed pump flow also reduced around 4 TPH. So overall there is a huge improvement in the plant, and there is savings of around 80 units heat rate just by changing this. So you can see it's a small thing, but the impact is very, very high on this. And if we carried out savings for this, so for 80 unit savings, the savings comes around 1.3 crores per annum. And then other savings in the boilers, first of all is the excess air at eco outlet that has to be controlled. There is no, they have to further optimize it to below 3%, and the payback is less than 1 year on that. Then next is the boiler APH outlet temperature is also, if they that distribution has to be proper for the gas in the APH, and there also the payback will be less than 2 months. They do it, and the implementation of AI also we recommend it. They don't have any control there, no Optimax is there, nothing. So there is a scope for applying the AI also in the boiler section. Then in the feed water heater, the LP heater overhauling and the second stage turbine extraction, the 2 points in the turbine side. So 2 tons of coal savings is envisaged there, that section, with investment of 20 lakhs. So they maintaining the ejector steam consumption at the design value. So current steam consumption is 1 TPH, and we recommend around 0.3 TPH at that point. So steam to fuel ratio is 6.6 in that plant. So with this investment, it's also payback less than 1 year, we can say. Then the plant is using some AFR, but they are not able to, just 2 to 3% AFR is there. And they are using some biomass also. So they are having some briquettes, biomass briquettes. So we recommend them to install a gasifier, because that will be a more homogeneous distribution, and they will get a better consistent CV for the fuel. So whatever biomass they are feeding, we can further improve it by gasifying the waste. So, but there is an investment in this for around 10 crores investment will be there. So payback is high in this case. So if there are long-term agreement with any supplier for biomass briquettes, then they can go for this recommendation. Then another is turbine rotor modification. So some plants have implemented this in the turbine side, just by changing the flow path in the rotor side. There is a further improvement in SSC, specific steam consumption, and reduce the fuel consumption also. So they payback around 1 year. So this has been implemented, and this has been successful in some plants. And suppliers are already giving this in their turbines wherever scope is there. So overall trial runs we demonstrated energy savings related to vacuum improvement by cooling tower pump flow optimization, and total energy saving around 14.2 crores is recommended with investment of some 21 crores. There are some no investment projects, some medium and two, three high investment projects which constitute 21 crores. So thank you very much for
It was a nice presentation from Mr. Prateek about the case study on energy audit and as well as of a captive power plant. I would like to call the next presenter, Mr. Praveena Kosuri. It will be delivering on integrating waste heat recovery with maximum recuperation efficiency.
Good evening, ladies and gentlemen. Hope you all have a great day. Every small step we take today will bring us closer for building a better tomorrow. My sincere thanks to NCB for uniting us in our mission towards net zero carbon and greener future for the industry. I am Praveena Kosuri from IKN, and I am very excited to present innovative and sustainable technologies for our journey towards net zero carbon. So let's begin. Integrating waste heat recovery with maximum recuperation efficiency. Generally, we are talking about clinker coolers. Functions of clinker coolers are recuperate the heat back to the kiln, cool and convey the clinker with the lowest power, recover maximum heat to enhance WHRS generation without sacrificing recuperation efficiency, sustain the performance for longer periods. IKN cooler can deliver consistent performance for more than 2 decades, which is far behind the performance guarantee period. So how to increase WHRS performance without sacrificing recuperation with IKN pendulum cooler? Here it comes hot air recirculation. This is the heat distribution in IKN pendulum cooler. In recuperating zone, we are recuperating nearly 75% of heat normalized to 0.85 nm³ per kg clinker air volume through secondary and tertiary air ducts. Losses available at vent is nearly 20%, which is equivalent to 42.3 million kilocalories per hour. And this heat can be utilized for many other purposes. Other cooler losses are through clinker. Clinker temperature we are getting at 65 degrees centigrade plus ambient. IKN pendulum cooler with hot air recirculation. Taking hot air available after boiler, instead of wasting to stack, taking back to the cooler at 120 degrees centigrade. 100% heat available at vent is being recirculated to cooler through specific cooling fans, except kits and last cooling fans. It is helping us to increase recuperation by another 1.4%, which is close to 5 to 6 kilocalories. And mid-air heat availability is increased by 8.5 million kilocalories per hour for a cooling capacity of 10,000 tons per day. At various capacities varying from 3,000 to 12,000, it is possible to increase heat availability at WHR by 15 to 25% with hot air recirculation. Let me take you through a study. Starting modestly in 1975 with just 0.3 million tons per annum capacity, JK Cement has grown into a true powerhouse in cement industry with impressive capacity of 24 metric tons per annum as on date. It has achieved a significant milestone in 2022 November with the commissioning of JK Panna plant, boosting the capacity 2.64 million tons per annum. And they have chosen IKN technology for clinker cooling. So these are the technical specifications of IKN cooler in JK Panna. Guaranteed capacity is 8,000 and potential capacity is 10,000. They are currently operating at 10,000 consistently. Aerated surface is 212 meter square with intermediate roll pressure. Design volume of HR is 1.37 nm³ per kg, which means entire heat available at the vent is being recirculated to cooler. So, cooler in JK Panna has built up with a strong IKN fundamentals. For over 40 years, ICANN has forged into a path of success anchored with rock-solid fundamentals. And these enduring principles have been a cornerstone for our journey, and same has been adopted by JK Panna. KITS, Clinker Inlet Distribution System. Static inlet concept was initially introduced by ICANN, and in JK Panna, special is having KITS 4.0. KITS 4.0 have 4 basic features which I'll explain in next slide. Konda effect, strong horizontal air jets for uniform aeration. LPS, linear pendulum suspension, a wearless grade suspension with highest precision. And simple drive, ICANN cooler is having a very simple drive which is located at outside the cooler. As I said, with a strong scientific background, ICANN has introduced kits to the market, and later everybody followed the same concept. We are proud to introduce kits 4.0 in JK Panna. As I said, the 4 basic features of kits are hybrid aeration and variable slope to adjust the slope of kits, and based on proven concept of Konda effect. Dynamic transport segments. In case of snowman, the segments marked in red color will move. That means static part is able to move. Here you can see how it works. In case of snowman, these transport segments will be activated. To avoid snowman, inlet portion will move partially. Hence, there is no stoppages because of snowman removal. Compatible with existing kits plates, and upgrades can be done by using existing kits plates. As I said, our drive is very simple but powerful. There are no rulers or bearings inside the drive. Hence, we can take 100% hot air. There is no any temperature sensitive elements inside the compartments. Cooler in JK Panna is also having mid-roll crusher. We can say intermediate crusher located at 2/3 of cooler. It will help to drag heat from coating pieces and oversized clinker. So benefits of recirculation, it is a closed energetic system, and 100% heat available at vent is being recirculated to cooler. To avoid mid-roll crusher will help to avoid red apples in the DBC during upset condition, and recuperate heat from broken coating pieces. So with overall hot air recirculation, these are the results achieved at JK Panna. They are consistently running at 10,000 TPD. Power has come down to 4.9, and without HAR, this power is 4.2 kilowatt hour per ton. And recuperation efficiency has increased to 76% at 0.85 Nm³ per kg. So overall WHRS generation is 17 megawatt. Empowering tomorrow by capturing today's unseen energy. Across India, 171 million tons per annum clinker is being cooled by ICANN, saving the power of 32 megawatt and 13,800 wagons of coal, leading to the reduction of 4.95 million tons of CO2 per annum. Join us in shaping sustainable future. Let's cool together. Thank you.
Thank you, Praveena, Kosuri. It was a nice presentation about the IKN cooler capability of increasing the enhancement of WHR, and as well as its recuperation efficiency is also very good with high performance. Now, I would like to call the next presenter, Mr. Mohammad Fazil. He will be giving presentation on chasing for every kilowatt, a case study. Sachin Pawar. Sorry for that. He will be giving presentation on chasing for every kilowatt, a case study of in-house fan inlet design improvement through CFD.
Good evening to all. Myself Sachin Pawar. I am from UltraTech Cement Mumbai office. I am presenting on behalf of my colleague Mohammad Fazil. The paper title is Chasing Every Kilowatt, the case study of in-house fan inlet.
Yeah, can you be close to mic? Yeah.
paper that now it is okay. My paper title is chasing for every kilowatt, a case study of in-house fan inlet design for improvement through CFD analysis. I think everybody knows about UltraTech. I'm not going to tell. Content of my presentation will be observation and objective, process data, workflow for CFD study, geometry and meshing, CFD modeling and simulation, optimization approach, result analysis, and implementation at site, and conclusion. Observation and objectives. During process optimization study of in one of our UltraTech unit, the team observed that high pressure drop in fan inlet duct. The pressure drop reduction has identified as a potential area for optimization. Objective is to improve the energy efficiency by reducing pressure drop in the fan system. For that, we have done CFD modeling and optimization to reduce the pressure drop in fan inlet suction box. This is the process data. The plant was running around 7,200 TPD. Specifically, we have considered Y-piece transition. This is target for optimization. Temperature at the fan inlet is around 161. The static pressure is minus 464. Duct cross-section area is around 18 meter square. Velocity at fan inlet duct is 15.8. This is before Y-piece. And gas flow is around 10 lakh. This is the picture before modification was done. This is a workflow for CFD. It's because basically we start with the geometric, develop a geometry, then grid generation, identify the solution, boundary condition, calculation, then post-analysis for existing case and results. Then our results are matching with plant for existing case. Then we will start with modifications. Then we will identify the modifications, then recommend for implementation, then post-implementation evaluation, whether our results are matching with our modified model or not. Then benefits we can calculate and close it. This is the geometry, this 3D modeling, mesh generation, and we have used NCCFX software for CFD analysis. This is the geometry of the fan inlet duct. Around 4.7 meter was the fan inlet dia. Y-piece length was around 9.3 meter. That was focused for optimization. This was a meshing. This fan performance is governed by complex flow patterns characterized by intense swirl, pronounced radial shear, adverse pressure gradients, recirculation zones, and inherent transient behavior. We have used a shear stress transport K epsilon model, K omega turbulence model for CFD analysis, turbulence model that is used. These are details of the model. I am not going to detail. Optimization operation approach. Basically, we have the area which is enlarged. 3D model I have shown this. We have done a steady state analysis for to analyze the pressure drop across the duct. What are the first we have done only duct portion, and to capture the change in see the effect of duct dimension changes on the fan. We have also simulated transient flow of the fan. The result analysis. If you see the two pictures, one is before velocity pictures, one is as it is condition. You will see that at the bend there is a very high velocity, around 40 meter per second. With the modification, we have modified the duct area by 350 mm. The velocity has reduced substantially. The same thing we have implemented in unit. This is implementation picture. We have increased the Y-piece inlet duct by 350 mm on both the ducts. The second picture is what is the impact inside the fan flow. Existing, what is the velocity profile for existing with 350 mm and 450 mm. If we go beyond 350 mm, there is a low velocity zone inside the pan. So we decided to keep up to 350 mm. The study, results of the study was implemented in our unit. By implementing this modification, we are able to reduce fan power by 125 kilowatt, which is translated into 0.4 kilowatt per metric clinker, and saving was around 40 lakhs per year. There are also CO2 emission by 0.3 kg per ton of clinker. The results, pressure drop across the duct before modification was around 56 in plant. After it was around 31. Before at existing case, which is through CFD analysis, we were able to get 52 mm water column. And after with CFD modification, it was predicted around 27. Both the plant data and CFD analysis data were closely matching. Thank you.
It was a nice presentation on a CFD study for reducing the power consumptions. Now I would like to request again Sachin Pawar to give a presentation on combating erosion in cement preheater inline calciner through CFD-driven design optimization.
Once again, good evening. I think I have given my introduction. Same, I am presenting my colleague's work, Mohammad Fazil's work here. Paper title is Combating Erosion in Cement Preheater ILC. This was ILC calciner through CFD. Content again, observation, objectives, process data, CFD modeling, optimization of result analysis, implementation and conclusion. Actually, one of the unit in our UltraTech unit, we are facing a lot of erosion in ILC, tertiary air ducts, connecting to inland calciner. Again, the tertiary air temperature is around 900 to 1000 degrees Celsius, and there is a very hot dust also with this tertiary air. The issue is resulting in substantial heat loss, necessitated frequent repairing, and there is a very significant safety hazard when we got this erosion issue in our plants. So we have done CFD analysis to pinpoint areas where we can optimize the duct design, why there is a corrosion in the system. This is the background of the, actually this is the model where tertiary air duct is connecting to calciner. First, there was a single tertiary air duct which is dividing into two branches. Again, it is dividing into four branches. Two branches are connected to upper side of the calciner. Two branches are connected below the tertiary, means center of the where tertiary air is coming. Basically, this is done for low NOx design. These are the side pictures. You will see the patches, frequent welding work, and this clinker dust is also accumulated on the floors. Basically, this duct design is, means angle of the duct is very, can say not smooth. This was upper picture shows upper duct, and lower picture shows the lower side ducts, and these are patchings also, you can see. Again, process data, this is also 7200 TPD plant. Tertiary temperature was around 860, and kiln inlet temperature was rising in this is ILC. Kiln inlet temperature was around 1040, and flow is around 40 kg for tertiary air, and kiln inlet it was like 58 kg. This is the result analysis. We have done flow analysis and also done erosion studies. For existing case, you will see the red marks where we found through CFD that erosion we are getting. That is also matching with our plant data. So we have modified the angles of the ducts. We have smooth angles were developed, and bottom also we have changed the duct area, and duct angles also changed. This is implemented. The second picture, first picture was original, second picture was implemented. The maximum erosion rate density was significantly reduced from 0.043 kg meter square to 0.011. Again, this presented work was implemented in one of the unit, UltraTech unit. Subsequent to implementation, a substantial decline in duct erosion was observed, eliminating the need for previously mandated bi-monthly repairs. Earlier we used to repair it every 2 months. After implementation, the system is running uninterrupted, and duct-related problems, there are no duct-related problems in the past 9 months. Then again, the CFD model has accurately predicted there was around 75% reduction in the erosion, which has also our plant team also has same thing as has been observed. And moreover, it significantly enhanced safety by eliminating the hazards associated with frequent duct repair during kiln operation. Thank you.
It was a nice presentation by Sachin Pawar on the CFD studies. One is related to about reduction in fan power, and as well as one is reduction of about erosions of the calciner. Now I would like to call the next presenter, Mr. Sunil Shah. He will be delivering presentation on energy conservation and condition monitoring through innovative ultrasound technology.
Good evening, Chair, Co-Chair, and CB representative, and my friends from the cement industry. So today I'll be presenting topic on energy conservation and conditioning monitoring through ultrasound. I'm presenting from the UltraTech TPMC team, and my team members are Mr. Pawan Mathur. So content of the presentation today: introduction, what is the maintenance challenge which the cement industry is facing, the background objective, what are the equipments used, the experimental work, observations, results, discussions, and applications. So in today's environment, the generating revenues of the cement industry is very important. The profit margins are sinking, and one of the best ways what operation engineer can do is by reducing the wastage in energy. So locating sources of the waste, identifying the failure conditions means eliminating the breakdowns or reducing the breakdowns in all the areas can also improve the bottom line. Ultrasound offers many opportunities for reducing energy wastage and improving the asset reliability. So they have expanded the concept of conditioning monitoring in the day-to-day activities. Using an acoustic imaging camera, these defects can be visualized and can be detected within a range of 100 meters distance. So what is the maintenance challenge today? So maintenance person has to, when during the periodic inspection, when he wants to listen to abnormal noises, so it is not possible by the, what we call the normal human ear, because these noises are in the range of very high frequency ranges. So they cannot able to envisage the actual hidden problems by detecting the abnormal noise. Similarly, in case of electrical systems, the trackings or the partial discharge which happens, that also cannot be seen by the naked eye and also listened to the ears also. Further, because the electrical system is enclosed in the panel, and we cannot, and as a part of the safety, we cannot open the panel to identify any issues in the running conditions. So this is one of the major challenges, and also there is no mechanism to identify the lubrication issues in the bearings, means how and when to lubricate. So identifying this business challenges, this ultrasound can prove a game changer for conditioning monitoring of these equipments. So I will just make you understand what is the ultrasound. I think many of you might be using this and may be aware of this technology. Now humans, a normal human can hear the frequencies in the range of 20 Hz to 20 kilowatts, which is in the audible range. And normally it is in the range of 16.5 kilowatts. And above this capacity, it is called the ultrasonic, which ranges from 20 kilowatts to up to 100 kilowatts also. Now any airborne or structure-borne equipments, they can emit high frequencies when there is an abnormality in the equipment. And these high frequencies translate into ultrasound, means they can detect by the ultrasound and they convert into the audible ranges. So you can see the three images, any turbulence, friction or any partial discharges, this can be detected by the ultrasound and it can be easily detected. The objective is energy conservation and CO2 reductions by identifying and correcting the leaks in the following areas like false air, vacuum leak, in case of CPBs, compressed air leaks, steam trap leaks. And second is the conditioning monitoring by advanced identification of the bearing issues specifically and electrical partial discharges. So this is one of the instruments which has been used for detecting the ultrasound. This is an acoustic imaging camera which can be used for the false air, leak as well as partial discharge detection. The next image, if you, when you see in the blue color, is basically the ultra pop for lubrication and bearing conditioning monitoring. So I will just showcase you the bearing conditioning monitoring using ultrasound. You can see in the first figure, from the stage 1 to stage 5, it is basically the bearing rupture. So in the stage 1, when the friction develops, in the ultrasound, it releases a very high ultrasonic energy which is detected by the ultrasound. Thereafter, if it has been continued, it changes its temperature, then sound is changed and then it goes to the damage mechanism. So ultrasound itself, it attacks or detects at the first stage when the initiation of the problem has been started. Similarly, in case of the bearing lubrication, the graph of the friction versus time. As soon as the friction is increased, it can be detected by the ultrasound and the maintenance person can easily go and lubricate the bearing, instead of waiting in case of time-based lubrication and then converting into a bearing failure. Similarly, in case of the partial discharges, there are two waveforms which has been displayed. One is the Fourier FFT and one is the Fourier waveform. These are nothing but the harmonic waves which can be detected to identify the issues in the bearings a particular way. I have one case studies also which I think everybody will be able to understand on this. So this is one of the pyro section ST motor wherein we identified a high bearing temperature. We utilized the ultrasound, identified what is the basically the decibel level before lubrication, and we did lubrication and what is the post lubrication, what is the sound. So I would like for the sound, please if you can, yes. This is a sound post pre-lubrication wherein the bearing was having high temperature. Then we lubricated the bearing and after 1 or 2 hours we again measured the sound and you can just hear the sound of post lubrication. So there is a significant difference in the sound pre and post lubrication, and you can see in terms of decibel level. In case of decibel level, RMS values before lubrication was 54, in the peak value was 75, and after lubrication the RMS value has reduced from 54 to 37 and peak values reduced from 75 to 53. So this was the impact of lubrication, timely lubrication by identifying through ultrasound. So this is one of the case study of bearing failures. So you have to identify whether there is an issue of the lubrication issue in case of bearing or whether the bearing has already initiated the failure. So there are 4 conditions, 4 baselines which we have defined based on different defects in the bearings. So one sound, the first sound is the case of the healthy bearing, how the sound will denote. Can you please play the sound? So this is the sound of the healthy bearing. Then the issue with the grease defect means under lubrication in the bearing. So there is a issue of the lubrication issue, and now third sound will be played for the early stage failure, means already the breakdown has started. And now is the irreversible failure, means I think the bearing is on the verge of the failure. So this is the condition where you cannot able to reverse the condition of the bearing. If you are attacking the bearing at the early stage through ultrasound, I think it can prevent on the irreversible failure of the bearing. And you can also baseline the issue with respect to the it is related to lubrication or the bearing issue. There are many case studies because of the paucity of the time might not include in the presentation, but right from the mechanical bearings to the slow speed bearings to the, these are grease lubricated bearings basically, not oil lubricated bearings, which can be detected by ultrasound. These are the other applications wherein steam leak, false air leak, nitrogen leak, turbine control. Basically, it is a type of the leak. It can be detected by the range within the range of 100 meters by standing from the ground. So in the case of the cement plants where the approach is not available, it is difficult to identify the leak at the unapproachable areas. So this can be able to detect easily through ultrasound. And one of the good feature of this is that it can able to quantify the leak through advanced camera, and you can also develop a leak management system wherein you are able to track and identify on the month to month basis what are the leaks been arrested and what savings has been achieved on this. So results and discussion, we have implemented this ultrasound analyzer at 4 plants, and just on the basis of the leak only I am telling that we have achieved 80 lakh savings by identifying and arresting the leaks in false air leaks as well as compressed air leaks. Apart from that, we have also scheduled, as we have seen that lubrication, motor lubrication is one of the issue wherein the current practice is basically on the time-based lubrication. So we have changed the methodology from the time-based lubrication to the condition-based lubrication, wherein the lubrication of the motor will be done based on the sound levels and not based on the particular time period. Based on this, we have avoided 3 number motor bearing failures at 2 of the plants. And also the partial discharges which I have not shown in the case study, we have avoided 1 transformer bushing flashover in the switch yard, which may be due to the tracking of this thing. So below you can see a PF curve wherein you can see this is a very reliability curve. So ultrasound can detect much ahead of any conditioning monitoring technology, whether it can be infrared, it can be vibration or the fluid analysis. So it is not the say is not that you should not use the vibration. Both vibration and the ultrasound are complementary to each other and both should be used. The application is different. The vibration is used for the low frequency areas or in case of misalignment or structural issues. Ultrasound can be detectable, can be used to detect early stage failures. So both can complement each other in case of conditioning monitoring. So the applications of the ultrasound, starting from the crusher to the cement mill, the applications are, I think in almost all the sections we can able to use this ultrasound, and like if you can see the bearing inspection, hydraulic seal leaks, the slow speed bearing, the idleness inspection, the electrical inspections, false air leaks, compressed air leaks. So all the areas and sections of the cement which can be utilized for energy conservation and condition monitoring the ultrasound. So concluding, ultrasound now has become one of the most powerful tool for the conditioning monitoring. Earlier they were utilizing the analog cameras. Nowadays the technology in ultrasound has developed from the analog to the digital, wherein very smart and very high definition cameras are being utilized along with the advanced analytics. So you just need to detect the fault and they can able to identify what type of fault it is basically in case of electricals. In case of compressed air and false air leak, it can be able to detect and pinpoint exactly where is the leak, and it can be able to also quantify what is the leak in case of compressed air. In case of false air, it cannot be leak. In case of negative pressure, it cannot be able to quantify. So that is one of the limitation. And as per the research, it is told that ultrasound can detect very early stage bearing failures and electrical faults to partial discharges before any other technologies, as already mentioned in the last slide. So cement plants, whether it can be or the captive power plants or WHRS, can improve these efficiencies and the mean time between failures related to the improved productivity and the downtime of the equipment to ultrasound. Thank you very much for the patience hearing.
Yeah, it was a nice presentation by Mr. Sunil Shah about the condition monitoring of ultrasound technology. Now I request the next presenter, Prateek Sharma. He'll be delivering presentation on rolling back to captive power from grid power in Indian cement industry, issues, opportunities and challenges.
So, good evening to all. So, this topic is against the current trend. The trend is rolling to grid, because grid is more energy efficient. Grid is the CO2 consumption is less per unit. But I want to highlight the issues of grid also in this. So, the topic is rolling back to captive power from grid power in Indian cement industries, issue, opportunities and challenges. So, first of all, just to remind our COP21 commitment, 500 gigawatt non-fossil fuel electricity by 2030, 50% energy requirements from renewables by 2030, reduction of 1 billion tons in projected emissions by 2030, 45% carbon intensity reduction for 2005 levels, and net zero by 2070. We have made some progress so far, as shown here, and we are having now 201 gigawatt of electricity from non-fossil sources. Installed renewable 201 gigawatt. So if you see this pie chart, the installed total power generation capacity, share-wise, in 2023 it was 28% renewables, you see here, and 59% is from thermal, and it is projected by CEA that in 2030 it will be 36% thermal and 55% renewables share. So renewable share is going to increase definitely, no doubt in that, and hydro and nuclear will be some portion there. We know we are already industries CO2 emissions. I will not go into details of this slide. We all know we are reduced from 1.12 to 0.67, and now we are at 0.6 tons CO2 per ton cement somewhere. So current status of CPP, if you see, it's 9% of the total 68 gigawatts. CPPs are, but in cement industry, the CPPs are mainly for power generation, whereas for other industries like fertilizers and pulp paper, they are used for process stream. So the application is different from the CPPs. And the efficiencies are low definitely because they are small capacities. But some plants have done well in achieving the TSRs in captive power plants in India, 25-30% also they have achieved in some plants. So just we did some calculations, some assumptions and some futuristic thoughts, discussions with different experts. And we took two scenarios, like in 2030, suppose we are having 20% on grid power and even we do 100% grid power. See, total out of 110% is electricity requirement, if you see. So even we do 10% electricity completely from renewables, still the impact will not be that much to renewables because electricity portion is very less in totality. So if we move from, suppose this CPP 57% in first scenario, and then even I move to 100% grid power, 57 to 77%, the CPP share goes to grid in 2030. Then also, if you see this slide, next slide, I've taken the baseline at 2017 because that is the authentic figure we are having, 670 kg CO2 per ton cement, and indirect emissions 82 kg CO2. So indirect emissions from electricity consumption will be 33 units at 20% grid power from power mix. And if 100% grid we are having instead of this captive, then it's 26.85 around. So what I mean to say is that overall CO2 reduction from 20%, 20% grid is not very significant, only 1 to 2%. And if some figures may change, then you can 3 to 4%. So even switching over to grid will not be, it looks like we are moving towards green, but not still be so much benefit if you see in the scenario. And if you compare the situation as of now, the CO2 emission factor from the grid, it is 0.68 kg CO2 per unit. And from the CPP, it's 1.2. Definitely CPP factor is high, almost level. That's why we are moving towards the grid. But there are some other factors also which is to be considered. I will show in next slides. Definitely grids are going into more renewables, but it is for sure that in nearly it will not be going to 100% renewable very shortly, because grid will get disbalanced, as the experts say. So it will take time, 100% renewables in grid. So and the cost, reliability issues somewhere still are there. So CPP, I feel, still there to stay. And if you, yes, definitely RP obligations, high heat rates, that will making the phasing down of CPP is there because of this high heat rates and all, and fuel crisis, environmental concerns, some issues are there. But you see the investment, total investment is 35,000 crores we have done in the CPPs. And if you see most of the plants, they are in 2 or 3 CPPs, only one is running, 1 or maximum 2, or that is also PLF is very low. So power plants currently are in really, you can say, dying state in cement plants. So we have to look for some alternate solutions for these power plants. So what can be done, because such a high investment has been done, manpower is there. So there is an issue in that scenario. So there are some alternative options which I feel is still open in near future for this captive power plants. Like we have also seen in this conference also, it has been told that in next 2 to 3 years, electrification is going to come in industrial scale. It is possible. But, and we are just thinking that it will be through renewables completely and we will be zero. But are renewables ready for 24 hours? Still not. The solar and wind, still intermittent supply is there. And 100% renewable is still not possible immediately. So we have to, we have to still run captive power plants in that case, if we have to use electricity for running our pyroprocessing system. So there is one way where we will be requiring this captive power plant. Then second thing is it will act as a steam generator. Suppose because the established carbon capture plant, carbon capture technology is still amine based only. And if some plants go for it or government incentives comes up for this, and we install this amine based systems for CCU, then we need steam for that also. So there also they can come into picture, CPPs. Then this gasification technology which is being explored for improving the TSR, there also steam is required. And finally, if within some range, plant range, some fertilizer plant is there, which is, so there, if they don't have their own source, then it can be explored to have steam from these power plants. These are some options which may be explored by the cement plants in future. So this first one is this electrification. So this renewable electricity can be sourced from CPP till continuous 100% renewables not feasible. So we are looking for this electrifying this calciner and kiln in future. So around for 1 TPD plant, 70 to 80 megawatts will be required, because electricity required will be more efficiency, if you see the efficiency in that case. So there will be more requirement than this reboiler part in the carbon capture system. This is stripper section. This absorber section is okay. Flue gas will be there and it will be absorbed, but the reboiler section, there we need in the steam. So, but for that, we have done some basic calculations, like we need around 190 degrees Celsius in the steam. The steam requirement is around 110 TPH in that case for a 1 TPD plant, for 30,000 meter cube per hour. And a 25 megawatt typical UC maximum plants are having 25 megawatt CPP. So they generate 120 TPH steam. So it matches with the requirement. So 125 megawatt plant can be given to that. But yes, some retrofit to be required, because CPP has to be saturated steam, not separated in that case. So we have to optimize in that way. Then the gasification process, here we need superheated steam in that case, if, for the gasification process also. Then for the fertilizer plant also we did some working. If the selling price around 3,000 rupees per ton, if you keep, then it will be workable. And it's the community boilers are running in this way in Gujarat. So 3,000 rupees per ton, and pipeline infrastructure cost 2.5 crores per kilometer. If you lay down for 5 to 10 kilometers maximum, because steam cannot travel long. So that also to be seen, layout also to be seen, safety to be seen. So those factors will be there. So this is one, and last but not the least, first of all, the CPP has to make more efficient. We have done many audits and we have seen still there is scope in these areas. So like single row type ACC to improve the vacuum, then modifying the steam flow path in turbine rotor to reduce SSC, then TSR around 30-35% if you are able to increase in the boilers. Some modification is required in the boilers, but if you are able to do this by using any process in gasification or any other way, then you can do this. PLF to be improved. If you have some other utilization, definitely PLF will improve. Then integration of ACCs. This also plants have done in many where they have 2 units and 1 unit is not running. Then they have utilized the ACC of other unit to improve the vacuum further. And then ID fan, all fans are running at part load at low efficiency. So that has to be seen if they can be operated at a impeller change or something to have more than 80% efficiency. And auxiliary power, now plants are maintaining 5 to 6% also they have achieved 5 to 6%. Earlier 7 to 8 was there. So keeping all this in points, I still feel 1.2, which is the factor now CO2, it will be less than 1 if we do all this on average. So keeping this all totality, CPP should still, I feel, they have a market still for 5 to 10 years more. Thank you very much.
Thank you, Prateek. Now I request any question answers are there. I will also request the presenters to be on the stage. If any questions are there, we will have a one-to-one discussion. Any questions? Yeah.
One advantage of the ultrasonic probe sensor, which Mr. Shah must have failed to miss it over there, it did not have an entire rotation of the bearing to get any defects of the bearing of the itself. Whereas in case of vibration analysis, we need entire rotation of the bearing to capture the conditions of the bearing over there itself. But ultrasonic, with a partial movement, half movement also, it can do it over here. One particular application in which case the bearing doesn't rotate for a full half is that of a wagon tippler, the roller itself. So this is also one more advantage that the UltraTech force sensor is having over and above that of the vibration analysis by coordination method itself.
Thank you. So that is what means vibration is basically works on the spectral analysis. So that is more related to the structure misalignment or related to the foundation, or when suppose motor fan issues are there. But suppose you have to target a specific equipment like the gearbox or the bearings, then early stage identification through ultrasound is one of the most prominent and advanced prediction as compared to the vibration. But both complement each other. What you said is correct. Ultrasound. Yes.
My point was catch over there itself.
Okay,
with the half rotation of the bearing also, it can capture your vibration, any problem over there itself. But for as the vibration analysis, the bearing has to go for a full rotation, then only it can say something about the condition of the bearing.
So this just to add upon this, ultrasound has actually many advantages. If you really choose the equipment and really implement at the site, I think the applications which are shown here, I think it can be much more what you have mentioned, sharing also. So thank you for sharing also.
Yeah, Mr. Shah, I'm J.S. Kalra. There is a small question in cement industry.
Yeah.
Leakages in preheater and compressed air is very common problem. Every plant has, even if a consultant comes at the gate, he says there is a sound in your plant which shows that leakages are there. That is a light of white. But how to detect the exact location of leakage in the preheater tower with ultrasound?
So I would say there is a method basically. It is basically a part of a training procedure, a gross to fine method we call. So the false air, the preheater you are talking about the false air you are meant, correct?
Yeah, false air.
So basically this is an acoustic imaging. It is not an analyzer. So if you have the access, this ultrasound, it can be able to detect from 130-meter distance from the ground. So if you by standing from the ground, if you just surface this ultrasound camera at the preheater location, just by identifying, it can be able to identify what are the pinpoint areas, or it can pinpoint the areas of the false air.
Okay.
Just only limitation is that cannot be able to detect what is the quantification, means what is the quantity of the flue gas or the false air it has been passing. In case of compressed air, it can detect.
Right. Thank you.
Thank you.
प्रतीक जी, आपने सजेस्ट किया कि टरबाइन का रोटर रिप्लेसमेंट करने से जो है अपन को हीट रेट में गेन मिलेगा, पर हमने मेनी टाइम्स डिस्कस किया, पर कोई भी वेंडर जो है 1 ईयर से ज़्यादा गारंटी देने को तैयार नहीं है।
इसमें दो तीन चीज़ें, आपका फ्लो, आपका टरबाइन जो सप्लायर है ना, सीमेंस का टरबाइन है, किसका टरबाइन है, उस पर डिपेंड करता है कि एचटीसी का।
सीमेंस का टरबाइन है, त्रिवेणी का भी टरबाइन है, पर वो मैक्सिमम जो है 1 ईयर का ही गारंटी है।
लेकिन जहाँ भी इम्प्लीमेंट हुआ है दे आर सेटिस्फाइड। जैसे चंदेरिया में हुआ, चंदेरिया सीमेंट प्लांट में, वर्किंग फाइन, ऐसा कोई इशू तो नहीं है। मतलब ठीक है, गारंटी वो नहीं दे रहे हैं, बट स्टिल वर्किंग ओके।
नहीं, मेनली जो है, जैसे हमने जो है सीमेंस की 7 टरबाइंस वी हैव इन अवर सीपीपी, पर ईच टरबाइन वी हैव प्रॉब्लम ऑफ बैलेंसिंग पिस्टन लीक ऑफ। आफ्टर 3 to 4 ईयर्स में जो है बैलेंसिंग लीक ऑफ पिस्टन का जो लीकेज है वो बहुत ज़्यादा बढ़ जाता है।
वो एचटीसी में भी प्रॉब्लम होता है,
पर उसका रेक्टिफिकेशन का जो है सीमेंस के पास भी सोल्यूशन नहीं है।
वो किसी की टरबाइन आपका वेरी करेगा, सप्लायर वो वही है, सॉल्यूशन है, लेकिन वही है कि हर टरबाइन केस टू केस वो सप्लायर ही बताएगा आपको, वही है कि कितना कर सकते हो।
So what you mentioned, they will warranty for 1 year only, but what you can ask is that what is the degradation factor every year. If you maintain the same conditions like temperature, vacuum, all these things, I think they are liable to give the correction curves, basically what we mentioned, correction curves. And considering all the conditions same, what is the aging factor for 5 years? I think that they can able to give OEMs.
Okay.
My question is for the ICANN implementation at JK Panna. You had designed for 8,000 TPD, that is producing at 10,000, and WHRS generation of 10 megawatt, which has gone up to 17 megawatt. Was it designed accordingly that this shows a very high increase? Why was it thought about that this will give it 17 because there will be limitation in the boiler or in the turbine generator gearbox limitation? Now anybody would have liked to have a very both clinker high as well as the WHRS higher generation, but was it taken in consideration during the design stage to get this?
Sir, 10 megawatt is in case of without hot air recirculation, and 17 megawatt is in with hot air recirculation, and that is not only from cooler, it is the overall power, overall megawatt, and with hot air recirculation.
I got that, because you normally you might have taken because we are always at either you take pessimistic or optimistic viewpoint to design the system of WHRS. So while everybody would like to get a higher out of WHRS, but that also depends upon how you run the kiln, whether it is running in heat efficiency of the of your specific heat consumption is on the higher side for the kiln. I think those also comes up for questions, yes. Because we are everybody coming up with the newer kilns now, has got this WHRS generation in mind, the higher one. Maybe we can have more discussions going forward here.
Yes, sir. Thank you.
I have one question from Mr. Prateek. In your case study, you have just given that instead of one pump, we operated 2 pumps. But if you see your base case data, your cooling tower efficiency itself is reached up to 75%, even in the base case. So what is the reason for improvement after starting the 2 pumps?
Sir, actually, if you correlate with the vacuum and the turbine exhaust temperature, it was 0.86 vacuum and they are running with one cooling tower pump. The total flow is 4800, running at 2400 at 0.86 vacuum and temperature 55 degrees Celsius. But once when you run the 2 pumps together, you see the approach. Approach immediately changed from 14 to 7. Approach improved and your cooling further improved and vacuum improved. So the actually 0.10 vacuum normally gives you savings of 500 watt. Normally, generally what we say. So here the improvement is significant, 0.86 to 0.9. See, ACC efficiency improvement limited in air cooling, but water cooling efficiency increase too much high. When you circulate the water, then the cooling is more efficient. So that's why the significant savings is due to the incremental vacuum, which we achieved due to cooling.
So this is a water circulation. That is there. That is instead of 1 pump, it is 2 pump. But is there any increase in air circulation, or it is only a water circulation? Because if you have only water circulation, then with a 75% efficiency in a original case, needs to be...
Approach was low and flow doubled, water flow doubled, so that's the improvement we get from there.
Okay, thank you.
Okay, thanks for the presenters for giving the answers. Now I request our chairman and co-chairman to conclude about the sessions, please.
I request co-chair to
Thank you. Well, I find this quite interesting from my perspective, trying to bring what we consider new solutions to India for co-creation. In my understanding, we have a good ground for that because I understand you have quite some good solutions also here. So I'm looking forward to bring the Swedish innovations here and integrate them with your work. Interesting.
Thank you, Mr. Lindstrom. So, to do the kind of concluding, of course, I have little to add to the excellent presentations that all the presenters have made. But I think just to conclude, we have touched upon various aspects of the cement sector, right from the optimization in the CPP, use of alternate fuels, RDF, and then we went to the innovations in using of ultrasound for efficiency, leakage improvement, and the safety issues, and several other points that the cement industry would be, looking forward in the times to come. So excellent presentation. So, certainly emphasizing once again that the underlining point in here is, as we are sitting in the energy conservation session, so the bottom line is the energy efficiency, how that efficiency can be brought into the system, and cement industry as such, many of you already know that Indian cement industry is one of the best in the world. So we are looking further, being the best, you have the nation and the rest of the community expects even to do better in your performance. So with that hope, I would stop my concluding remarks, that excellent presentations that the presenters have made, and I think the industry's involvement in this research and the other activities and the excellent questions that the audience have brought into the discussion is highly, at least for me, it is an education and a lot of learning. So thank you all for presentation, and thank you. And I would, on behalf of the here, request excellent round of applause for the presenters and also to the excellent audience here. So I will stop here. Thank you.
So thank you, sir. Now I would like to request Chairman, Co-Chairman and Shri KPK Reddy to present certificates of participation to all the presenters. First is Dr. Prateek Sharma. Next, Miss Praveena. Mr. Sunil Shah. And then Mr. Sachin Pawar. So I would request Shri KPK Reddy to please present mementos to our respected chairman and co-chairman. So thank you, sir. Ladies and gentlemen, that concludes this session. Thank you.